Okay, so in this video, we're going to take a very quick look at our prime numbers. So a prime number is just a whole number that is greater than 1 and has only two positive factors, and they would be 1 and itself. So to begin with, we're just taking a look at the numbers from 1 to 10. So starting with 1, 1 would actually not be a prime number. Because when we look at our factors, we're looking for our positive whole numbers that we can multiply together to give us our number that we're looking at. So the only positive whole numbers that can be multiplied together to give us 1 are 1 times 1. So because that number's the same, 1 only has one factor, and that would just be 1. So because it doesn't have two factors, it's therefore not a prime number. So now moving on to 2. Well, 2 would actually be our first prime number. Because to find the factors of 2, we want our whole positive numbers that we multiply together to get 2, and the only ones that work are 1 multiplied by 2. There are no other factors, so because 2 only has two factors, it is therefore a prime number. So 2 is also the only prime number that is even, because every other even number after 2 would also have a factor of 2. Therefore, no other even number can be prime. So looking at the list we're working with here, we can cross out all our other even numbers. So we can cross out 4, as that wouldn't be a prime number. So 6 is not going to be a prime number, nor is 8. And then 10 isn't going to be a prime number either. So now let's carry on through the list. Well, looking at 3, the only factors of 3 are 1 and 3, as those are the numbers we'd multiply together to get 3. So that is also a prime number. Next, looking at 5, the only factors of 5 would be 1 and 5, as those are the only positive whole numbers that we can multiply together to give us 5. The only factors of 7 are 1 and 7. So because again it only has two factors, 7 is also a prime number. And now for 9. Well, the factors of 9 are 1 times 9. 9 isn't in the 2 times table. However, it is in the 3 times table. We can make 9 by doing 3 times 3. So I'm not going to write that down twice, I'm just going to write it down once. So 9 actually has 3 factors, which are 1, 3, and 9. So going back to our rule, because 9 has 3 factors, it is therefore not a prime number. So from the numbers from 1 to 10, the only prime numbers that are in this sequence are 2, 3, 5, and 7. This list doesn't just stop at 10, it obviously goes on, and we can find many more of our prime numbers. But this should give us a good introduction of how to find them. Okay, let's take a look at a few more examples. So we've got a few more questions to have a go at here. If you want to pause the video and have a go at these first, we'll then go through the solutions in just a few moments. Okay, so for question 1, we have to circle all the prime numbers in the list below. Well, in the first example we did, we went over the fact that 2 is the only even prime number. So looking at this list straight away, we know that all the even numbers are not going to be prime. Let's cross these out. We know that 8 isn't going to be prime, 16 isn't going to be prime, and neither is 24. So we can get rid of them straight away. So let's now take a look at the factors of all the other numbers. So 15. Well, we can look at the factors of 15. They are 1 times 15. 15 isn't in the 2 times table. However, then when we go to 3, it is 3 times 5. So 15 has got more than 2 factors, so we know it's not going to be prime. Now looking at 19. Well, the only factors of 19 are 1 times 19, because if we go through all our other times tables, we can't find one where 19 would appear until we get to our 19 times table. So the only factors of 19 are 1 and 19 itself, so it is therefore a prime number. Okay, now looking at 27, well, we've got the factors of 1 and 27. We can then move on to 2. Well, it's not in the 2 times table, but then when we move on to 3, we can make 27 by doing 3 multiplied by 9. So because, again, 27 has more than 2 factors, it is not a prime number. And then finally, we've got 31. Well, the only factors of 31 are 1 and 31 itself. It doesn't appear in any other times table until we get to 31. So because it only has 2 factors, it is therefore a prime number. So the only prime numbers in this list would be 19 and 31. Okay, for question 2, we needed to write down 2 prime numbers that add up to 30. So what we can do here is just take a look at some prime numbers that we've already figured out, and then see if the remaining number that would make up 30 is also prime. So again, let's go back to the example we did right at the beginning, the numbers between 1 and 10. So we figured out that 2 was a prime number. So if I start with 2, I would have to add on 28 to make 30. So is 28 a prime number? Well, we know straight away that it isn't because it is even. And as we said at the beginning, any even number other than 2 cannot be prime. So we can't use 2. So let's move on to 3. So if I start with 3, I would then have to add on 27 to make that up to 30. Well, the factors of 27 are 1 and 27. It isn't in the 2 times table, but it is then in the 3 times table. It is 3 multiplied by 9. So because it has more than 2 factors, 27 is not a prime number. So we can't use 3 for this question. Next, let's take a look at 5. If we start with 5, we would have to add on 25 to make 30. But is 25 a prime number? Well, it isn't. It's a square number. We've got the factors of 25 would be 1 times 25. And then we can actually do 5 times 5 to make 25. As we said, it is a square number. So the factors of 25 would be 1, 5, and 25, meaning it has 3 factors, so it is therefore not prime. Okay, so let's try 7. If we started with 7, we would have to add on 23 to make 30. Well, is 23 a prime number? Well, it is, because the only factors of 23 are 1 and 23. So 23 would be a prime number. We already figured out at the beginning that 7 was a prime number. So we can use these 2 prime numbers to add together to make 30. So again, this isn't the only answer. There are other examples that would work. So for example, we could have used the numbers 11 and 19, as they both add together to give us 30, and they are both prime numbers. Okay, and then for this final question, we want to write down all the prime numbers from 30 to 40. Okay, so if we take our numbers from 30 to 40, we want to find all the prime numbers. So straight away, we can get rid of all the even numbers. As we know, all of these would also have a factor of 2. So we can get rid of 30, 32, 34, 36, 38, and 40. So now going through the list, we're starting with 31. Well, 31 would be a prime number, as the only factors of 31 are 1 and 31. Okay, then 33. Well, we can do 1 times 33 to make 33, but we can also do 3 times 11. So it's got more than 2 factors, so 33 would not be a prime number. So then looking at the factors of 35, well, we can do 1 multiplied by 35, but 35 is also in the 5 times table. We can do 7 times 5 to get 35. So that would have more than 2 factors, so 35 would not be prime. Okay, we then look at 37. Well, 37 would be a prime number, as the only factors of 37 are 1 and 37. And then we're looking at 39. Well, we can do 1 times 39 to make 39, but we can also do 3 multiplied by 13. So 39 is going to have more than 2 factors, so it would not be a prime number. So the only prime numbers from 30 to 40 would be 31 and 37. So well done if you followed along with those questions, and that's it for this video. If you want to check out any other videos on working with factors of a number, then I've left some links for them down in the description, and I've also put a card in the top corner, so feel free to check them out. I hope you found this video useful. If you did, please feel free to leave a like and consider subscribing. If there are any topics at all you'd like me to go through next, then please just let me know down in the comments, and I'll try to make some videos on those topics as soon as possible. So thank you very much for watching, and I'll see you in the next video.